Welcome, ladies and gentlemen.
Thank you, guys. So thanks a lot to Sardinia for organizing this event. I think it was really needed in this geographical area. Also, like when a conference actually tells a story I can resonate with, right? First, I have to thank Kenneth for talking about costs. This is very important, I think, also for the type of things I will talk, thanks to the clicker. And also the Vespertech guys, because they reminded me, they sent me back on a trip down to memory lane. It was nearly 10 years ago, an OpenStack summit, I believe, in Vancouver. Microsoft sent us a crate with an open compute server that we configured with our OpenStack at the time. So consider OpenStack was still relatively pioneeristic back then. And not only, of course, we had to get it run and everything with full provisioning. We wrote basically drivers and agents for both Ironic at the time and Mass to provision everything from scratch and everything because of the custom BMCs they had, right? But also, in the total spirit of open source, they just dropped the crate in front of our booth. So we have to go and find a crowbar, get it for somebody some power tools and find a way to, when you guys were talking about, the difficulties of moving a crate around, that was my second memory I had with Open Compute. Anyway, so we're going to talk about, if I manage to move the slides. Okay, good, thank you. So we're going to talk about migrations primarily, okay? In the past years, there was a lot of talks about, hey, let's move, to public clouds, to hyperscalers and everything. And nowadays, thanks also to the cost discussions we were having, there is a lot of moving back. There is a lot of moving from hyperscalers back to on-premise. There are like a lot of edge use cases. There are a lot of scenarios when people have to move data around. So that's one of the reasons why people need to move workloads around these days. And another reason is that people move their data across different generations of computing necessities, right? So we started typically from physical servers back in the day, then we had VMs, then we moved from VMs, let's say VMware and everything, to infrastructure as a service, hello OpenStack, Then from there we get to containers, then you get to Kubernetes, and nowadays there is of course a lot of serverless, for example WASM, right? WASM might be the next big thing in that space. Okay, so why would you move those workloads, right? Well, improving TCO, of course, will be your need. You might have a new on-prem infrastructure, new on-prem hardware. You might move from on-prem to public cloud, from public cloud to on-prem. You might have a redeployment, lots of options. Now, that's not so simple, of course. You might decide what to do. You might say simply, well, I'm tossing away the software I have because it's old and just replacing it with something new. I might re-architect. For many years, evangelists of many companies were just saying, oh, you have to rewrite your applications based on new, criteria for, cloud development and everything, which is not easy if you have like 20 years of development on your application behind you. You can re-platform, which is what you should do if you move, for example, from VMs to Kubernetes, but that requires a lot of consulting and manual work. Or you can lift and shift. Lift and shift means taking your VMs or your physical servers and just translate them like black boxes into your normal environment, making sure that they work exactly as it is. For examples are like migrating from VMware to OpenStack, or AWS to Azure, AWS to OpenStack, Azure to OpenStack, and whatnot, right? So those are some of the examples. Pros, as I mentioned before, servers are just like black boxes, no need for changes, easiest way to do it. Cons, well, you won't take necessarily advantage of the advantages that the new model can give you, right? So if you have an old applications in an old VM, you're still getting an old VM inside of your new environment. So you're not taking, for example, advantages of the brave new world of the infrastructure as a service or platform as a service scenarios we were talking about, right? There are also a lot of steps involved, I mean, the idea is relatively simple. I take a virtual machine on one side, I move it to the other side, but in reality, there are a lot of things you have to do and to take care. You have different virtual disk formats to begin with. You have different synthetic kernel drivers, VMware tools on one side, Virtual.io, LIS if you are on Hyper-V, things like this. InitRD. If you are on Linux, you most probably need to rebuild your initRD images, right? SC Linux, that might scream at you, hey, where is the hard disk I was running until yesterday, right? And that will prevent you to boot. You have PCI IDs, network configurations. There are a lot of things that might change. You have provisioning agents, right? So if you move from VMware into, for example, OpenStack, you need to have Cloud Init or Cloudbase Init if you're running on Windows. And so on. So for that, back in the day, like a few years ago, when we started becoming successful, deploying OpenStack to our customers started asking, okay, great, I really like your OpenStack, but I have all my VMs, thousands of VMs in my old VMware servers. What do we do with it, Migrate them manually, it's possible, but very time consuming. So we decided, okay, why don't we just write a new project in the same spirit of the infrastructure as a service stuff that we do with OpenStack. And we write it as a cloud-native solution to move migrations around. And the project is called Coriolis. Coriolis is, the Coriolis force is what makes actually basically clouds spinning, if you noticed, around the atmosphere. I could talk probably hours about Coriolis forks thanks to my hobby in flying into real clouds, but probably we don't have the time for that. So it's scalable. So it's fully automated to begin with. You press a button and it just migrates everything, right? It's scalable. You migrate one VM, you migrate 1,000, doesn't matter. There is a full REST API for full automation, Keystone Identity Management. So we wrote it basically as an OpenStack service that you can just integrate in any OpenStack cloud or use it independently. For example, if you want to migrate to Kubernetes with KubeVirt, for example, right? Or on Azure, AWS, you name it, right? Architecture, again, bunch of microservices, as you will expect. There is a client, a GUI, and a CLIM. Okay. REST API, Keystone, as we're saying, for identity, a conductor, a scheduler, and a bunch of workers plus Barbican for sharing secrets, So all components that the people among you that might already be familiar with OpenStack know. And the workers are providers which talk to the various clouds. So VMware, AWS, OpenStack, System Center, Hyper-V, Oracle Cloud, and so on. Beside the ones I mentioned, we started, as I said before, from moving from VMware to OpenStack, and then we started adding all possible things. Because again, the architecture of Coriolis is decoupled from the individual clouds and virtualizations we're using. So it's just a matter of adding a new provider whenever there is a need, right? So that's how we added all those things. The last one we added is actually Kubernetes with KubeVirt. Anybody here familiar with KubeVirt? Good. So KubeVirt is a way to get virtual machines running natively inside of Kubernetes, right? You might say, why would you do that? I want to use Kubernetes just for containers, but very often you might have a single environment in which you want to share both, a single space where you want to keep both your containers and your VMs for the type of applications that cannot be replatformed, right? Old Windows machines, stuff like that. One thing that we do during the process, the magic step involved here, we call it OS morphing, and is what we do in order to get the machine to readapt to the target environment. So what's happening is that we attach the machine to the target environment, a worker VM that we spin up will look inside, looking for content, and decide what actions need to be done. For example, adding virtual drivers, adding Cloud Init, and all those things. Coriolis is completely agentless, so there is absolutely nothing that needs to be run inside of a VM on the source, which is very important because when you have thousands of VMs, you really don't want to have to install an agent inside of them. Often you just cannot, right? Or you might have policies, or you don't know the credentials of your tenants, right? Plus all the security implications. So running agentless, it's very important here. Supported operating system, well, pretty much everything, and everything which makes sense, of course. But also here, the architecture is completely decoupled. So in the moment in which we want to add a new operating system, we don't have to rewrite anything inside of Coriolis. We just need to add a simple plugin which says, okay, we support these new versions, the new versions of Windows, this new Linux distribution and stuff like that, right? Of course, the older we go in time, the more difficult it is. For example, RHEL, CentOS, and everything 5, if you have the misfortune of still having some of those around, are pretty difficult to migrate, right? While when you move up towards 7 and plus, it's much easier. So again, Red Hat and similar, so CentOS, Oracle Linux, Debian, Ubuntu, SUSE, both SLE and OpenSUSE, Fedora, Windows guests, if you have, for example, guest environment with client environments you need to move, and Windows Server, the whole line. Of course, including here also the list of versions which are not supported by Microsoft anymore, but very often you have customers which have them. So we just said you shouldn't still use this, but if you want to migrate it, it works. There is a command line interface, as I mentioned before. This is very useful because if you do like 2-3 migrations, the graphical user interface is perfect. If you do thousands of them and you want to integrate it, for example, in Ansible and stuff like that, you might either want to use a command line interface or just the REST API behind it, right? And again, the command line interface was written exactly like an OpenStack command line interface. So if you're familiar with those, you will be familiar also with this. It's entirely written in Python. Similar, the graphical user interface was meant to be as easy as possible, right? So no need to know anything behind this. So the only thing you need to do is from where you want to migrate and where you want to migrate it to, and having credentials, of course, for both environments. Normally, when I do this type of sessions, I also do a live demo, right? But of course, in 20 minutes, it's a bit too tight. I mean, the time is not for actually starting the migration, it's for copying actually the whole system around. Then the other thing that, customers at some point were very happy with the migrations, but they said, okay, great. Can I use this also for disaster recovery as a service? And we say, well, why not? So to do that, of course, we added a bunch of features in Coriolis, which allow you to do exactly that. So instead of doing just a migration once, we snapshot the disks, we copy it, we synchronize the deltas all the time, and then whenever you want, you can finalize your migration by just, again, automating and clicking a button, whatever else, and say, okay, now I'm spinning up the machine on the target. In that moment, the famous OS morphing I was talking about starts, and the machine will be changed in order to run on the target environment, okay? Till then, you can simply synchronize it. So you have basically a disaster recovery as a service between completely different environments. So VMware on one side, for example, OpenStack on the other, which is something that customers ask us very often. Or you might have 2 different data centers with OpenStack, right? Or 2 regions. Want to migrate across them. Disaster recovery, one fails, the other runs. Okay. When you talk about disaster recovery as a service, there are 2 very important metrics, RPO and RTO, so recovery point objective, which is the last replica executed. So we call them replica, these replications of these processes in which we copy our data. The first one is a full one, and then we have only deltas in which you copy over only the bits that basically change over time, right? And to do that, we take advantage of the underlying infrastructure. For example, as CBT for VMware, in which case we take same advantage of the same facilities used for backup. So in that case, it would be also not only crash consistent, but even app consistent, right? Or, for example, Cinder snapshots and backup features that you have in Cinder itself, for the case of OpenStack, and whatever the individual clouds offer us to basically attach to, right? The RTO, so recovery time objective, so that the amount of time it takes in the moment you press the button for your machine to start. We optimize it as much as we can, but of course it needs the machine to start. And it needs, of course, that process I mentioned before. So a temporary machine, which is already typically deployed, we keep them already alive in a pool. We attach the disk, install Cloud init, rebuild initRD and everything, shut it down, start the final machine, okay? So this is basically the time it will take in your target environment. 30 seconds, 5 minutes, depending on the environment, right? Here it's a quick representation in a diagram about how the whole replica works. So you create a replica, you create a migration, validation, and on the other side, finalization, okay? I leave it here in the slide as a reference primarily. Of course, we don't have too much time to go through the individual steps, but happy to talk about it later, right? If you guys have any questions. Now, I mentioned already before Kubernetes. So we as a company come, of course, from an OpenStack background. You know, we're doing this since more than 10 years at this point. So we contributed like to OpenStack since 2012, right? And of course, when the whole container story started, we got also involved also in Kubernetes. And by the way, there is a panel about Kubernetes later this afternoon, so we'll talk more about that later, right? So, and we said, okay, how do we integrate our whole Kubernetes story in this journey for customers, you know, that want to move across different environments? You know, could be between, as I said before, two on-prem environments, you know, VMware to Kubernetes, for example, maybe OpenStack Kubernetes, maybe running Kubernetes on top of OpenStack, moving from, let's say, a hyperscaler, AKS or EKS or whatnot, you know, to, for example, Magnum or OpenStack or on bare metal, you know. So there are even there many options to move around, you know. So we have also a long story in that domain as well. The first one is that, how many of you guys use Magnum on OpenStack? Some hands? Good. Yeah. Magnum on OpenStack, you know, the usual answer is that when asked this question, it's like, yeah. Why? Because it has a lot of problems due to the implementation related to heat, especially when it comes to upgrades. The good news is that the community is moving ahead with that, with a new implementation based on the Cluster API, which we work together with Wexels, another company in the domain, and Stack HPC. We had the support for a particular Linux distribution on that, which is called Flatcar, that we are part of that community, which is nothing else than the old CoreOS, okay? That got renamed to Flatcar. So Flatcar has an immutable OS image for Kubernetes. It's perfect. Capi solve all the problems we have in Magnum without the need of changing the API. So everything works exactly as before. You just add this driver, fully open source, and everything works, right? So this way we managed to basically unsuck Magnum, right? And it's great. Then we have what do you want to do if you want to have a Kubernetes on bare metal? So we have a full story about that as well. I will talk probably about this later, plus if you have any questions, like, feel free to come to me. And we have KubeVirt running on top of Kubernetes, right? So KubeVirt is another open source project, started originally from Red Hat. Pretty much the same folks that came from Nova and everything are involved there. So it allows you to run VMs inside of Kubernetes, and Coriolis allows you also to migrate VMs from whatever environment to KubeVirt, right? Good. I think that was it. So we have 1 minute and 23 seconds, so just a knife.
We do. A question that came up, which also occurred to me as you were talking. What are the trends you see in migration? You know, who's migrating from what to what the most?
Yeah. So that's a great question. And the answer to this question will be very different based on the time in which it gets asked. Like 5 years ago, everybody was migrating like crazy to public clouds, no? Nowadays, so many companies are doing the opposite journey, right? And that makes me extremely happy. So I see two particular scenarios. First, people that drank the Kool-Aid back in the day, and now they saw, oh my God, this is costing too much. And they move back, and they use companies like Sardina or Cloudbase, you know, offering managed OpenStack and everything, or they decide to do it internally, and they find out that they can spare a lot of money, thanks also to open compute hardware, but also traditional hardware, right? So there are a lot of options. So cost reduction helps a lot in that direction. And then there are a lot of companies that don't like the cost of VMware, or they simply have at this point very legacy VMware platforms, or they don't agree with the recent changes in licensing policies, let's say that company had, right? And they want to move finally to either OpenStack or KubeVirt. So those are the main scenarios we are seeing.
Great answer. Let's have a coffee break now.
Okay.
And if you've got any more questions for Alessandro, you might be able to pick them up in the panel. You're joining
Yes.